In this video, I'm going to be recording some practice problems for College Algebra Unit 10. And I'm going to go through these pretty quickly because I do have a class in here taking a calculus test right now, and I don't want to distract them too much. We'll start by giving a sketch of these graphs. 0.95 to the x, 0.95 the base of the exponent is less than 1, therefore it's going to be exponential decay. As x increases, we get closer to 0. As x goes to negative infinity, f of x gets bigger. Okay. Another one that's exponential decay would be, I suppose, the red one, but also the gray one. Okay, I'm going to skip the gray one, because this is like 1 over 1.35 to the x. And 1 over 1.35, that's a number less than 1. Okay. If the base is less than 1, it's exponential decay. So when I draw the graph, it's going to look exactly the same, up to some sort of proportionality. Okay, the red one is very similar to the blue one, except it's y is negative where it had been positive before. So I'm just going to reflect across the x-axis. Okay, this green one, since the base is bigger than 1, this is exponential growth. And we're familiar with that. It looks like the graph of the x. It grows as you move to the right, as you move to the left. You're dividing by 1.35 over and over again, and it gets closer to 0. Okay, lastly, the purple one is really just the same as the green one, except y is negative. So I'm going to have my y-axis so I have more negative space. Now saying it's decaying in a negative way. Or, I mean, growing in a negative way. That's the sketches of the graph. Now, on a multiple choice test, you'd probably be more likely to just have to recognize the correct graph, or match the graph to the function, or something like that. Next, we're going to talk about these compound interest problems. And what I'll tell you is, on the test, it gives you the formulas. You do not have to memorize these formulas. That's not part of this course. Okay? You deposit $2,700 in an account that earns 2% annual interest compounded monthly. Write an equation for the balance after t years. So that's just putting all the pieces together and leaving t as a variable. Okay, well, we know that the amount is equal to the starting amount, the principal, times 1 plus the interest rate divided by the number of compounding periods per year times nt. So when we say, okay, the starting amount is 2,700, the rate is 2%, and if it's compounded monthly, that's 12 compounding periods per year. That'll be an equation. And I see I forgot to erase finding the balance after 13 years, so I'll just kind of point at that for you. What we're going to do is we're going to plug in, wherever we see t, we're going to plug in 13. And then finding this is just a job for the scientific calculator, and I trust that y'all are able to do that. And my recommendation is that you plug it into the calculator exactly like you see it, with the parentheses, with the fraction bar, with the 12 times 13. No sense in making some sort of silly mistake and getting the wrong answer. Okay, now we've got one that's going to increase continuously. The value of a collectible coin increases according to v of t equals 2e to the 0.09t. How long until the coin is worth $10? Okay, well, v is going to be the value, and t is the time in years. And okay, what I'm going to do is I'm going to say I want v to equal $10. Okay, so I'm going to say 2e to the 0.09t equals 10. And I'm going to try to solve for t. Okay, well, e to the 0.09t would equal 5. Right? Backwards on the order of operations. Got to deal with multiplication and division before you deal with the exponent thing. And then I'm going to take a log of both sides. I'm going to take a log with base e, which is a natural log. And then what I'm going to do is I'm going to say, okay, that means that 0.09t is equal to the natural log of 5. Because this is one of our properties, that natural log of e to a thing is just going to be that thing. What exponent do I put on e to get e to the 0.09t? Put the 0.09t exponent on e to get e to the 0.09t. And then if I'm going to solve for t, I'm just going to divide by this 0.09. And, you know, if your answer choices were decimals or approximate answers, you could type it into the calculator and see what that is equal to, but it might be that on the test, it gives you exact answers, and so you would have to be able to do it like this. Okay, so that's something I want to show you. And here we have these log property questions, the way that we're going to ask them on the test, right? Where we're going to ask you to use the properties to evaluate some sort of log in terms of information that you're given. So they're going to tell you that the log base 2 of 3 is x, the log base 2 of 5 is y, and the log base 2 of 11 is z. So if they ask for log base 2 of 33, you got to make the 33 out of 2, 3, 5, and 11. Okay, well, what I'm going to do is I'm going to say that's the log of 3 times 11, which will be the log of 3 plus the log of 11, which is going to be x plus z. Okay. Log base 2 of 25, well that's 5 times 5, which is going to be log base 2 of 5 plus log base 2 of 5, which is going to be y plus y, or 2y. Now you could have also said that 25 is 5 to the 2, and then use the exponent property where you swing that exponent around the front and say it was 2 times the log of 5, which would be 2y. You're going to get the same thing no matter how you approach it. And then the log base 2 of 0.6, how did I make 0.6 out of 3, 5, and 11? Okay, well, 0.6 is 3 divided by 5. So this is log base 2 of 3/5. You can split this log over subtraction. And knowing what the log of 3 and the log of 5 are, that's going to be x minus y. I've got 3 more for you. Log base 2 of 10, log base 2 of the square root of 11, log base 2 of 1/3. Now log base 2 of 10, this one's a little tricky, because it's like, how do I make 10 out of 3, 5, and 11? You really can't. What you're going to have to do is you're going to have to use that 2 as well, and then actually analyze one of these logs. So what I'm going to do is I'm going to say that this 10 is 2 times 5. Right, and this is the log of 2 plus the log of 5. Now I know what the log of 5 is, that's y. But then you're going to have to think to yourself, what exponent do I put on 2 to get 2? And you'll put the first exponent on. Okay, so that's 1 plus y. Over here, you have to know that the square root of 11 is 11 to the 1/2 power. And then you're going to need to swing the exponent around the front. Use that property. So it's going to be half of the log of 11, which would be half of z, or z divided by 2, whatever you think. Okay, the log of 1/3, I would recommend writing this as 3 to the negative 1 power. That's something you need to know in this class. And then we can use that same exponent property. And so that will equal the negative of the log of 3, which we said in this case is x. Okay, now you could have split this over subtraction because there was division in the argument. And what you would need to do is you would need to know that the log base 2 of 1 is 0. And log any base of 1 is 0 because you take a number and you put the 0 exponent on it and you're going to get 1. Now the last example I've got for you is we've got an exponential function defined by a times b to the x, where a and b are positive numbers. If h of 5 equals 96 and h of 6 is 192, find the values of a and b. Okay, so this is going to turn into a system, and kind of a system we haven't seen before, but we could definitely figure this out, right? So h of 5 equals 96, so when I replace x with 5, I get 96. Okay, so it's a times b to the 5 equals 96. And h of 6 is 192. So a times b to the 6 is equal to 192. Alright, now I feel like there's a couple of ways that you could look at this. Since x increased by 1, that means I just multiplied by b again to get from 96 to 192. And 192 is 2 times 96, so it got bigger by 2. So I'm expecting b to come back 2. And then we'd have to do a little more work to find a. But I'm going to actually show you how to do this algebraically. What I'm going to do is I'm going to, in the past we've done substitution, elimination. We've added two equations together. We've subtracted two equations from one another. Right now, I'm going to divide these two equations by each other, which is perfectly fine as long as the equation you're dividing by is not 0 equals 0. And it's not. So I'm going to divide the red by the blue. Okay, a divided by a is 1. b to the 5 divided by b to the 6 is 1 over b. And 96 divided by 192 is 1/2. You could check it out using a calculator if you wanted. So if 1 over b equals 1 over 2, that means b needs to equal 2. Okay, then if I have to find a, what I'm going to do is I'm going to say, well, just plug in 2 for b, so I'll just use the easier looking at the 2 with the smaller number. A times 2 to the 5 equals 96. Well, 2 to the 5 is 32. So that means that a is going to be 96 divided by 32. And that means that a is 3. Okay. And that's all I got for you for this video. Let's say things that you need to remember are certainly going to be the change of base formula. We got to be able to do that. We got to be able to evaluate logs using our calculator using the change of base formula, because we only have a scientific calculator. And a little bit of our properties, and definitely a lot of solving equations. And so if you need any help, come see me. But happy studying.